Okay. Yeah, I guess this is a little warm up for what I should be doing Tuesday to Thursday, right? Um, I have rearranged the furniture. So, I can be a little bit more effective. So yeah, this is. Oh right, I forget that this is the second live that I'm doing. So that I need to do. I need to put the date. whenever I'm doing anything, I might as well put the date on it. So that way, it is, the record reflects, right? So I'll put the date. What is today's date? Today is it's June 9 already. It is June 9, 2025. June 9, 2025. Yeah. Believe it or not. So we just start the month and it's soon done already. Yeah. Now, if you notice this is for WhatsApp channel, YouTube channel, Facebook page, Instagram page, TikTok page. For this right here. Yeah. So yeah, that's it. So maybe that's what I'm going to do. I'm going to have to start writing the date so that I remember. I mean, sometimes the time is important, but what was I? Oh, I wonder if I can find that. Yeah, it would be nice if my tablet worked. I'll try unlock it. So I can see. Yeah. I remember that. All right. Base numbers. I mean, you have binary and base 10. You have base 8. Yeah, those number systems have the same rules. Alright, let me see if we can get rid of this. See if we can get rid of that. Alright. Now let's go use a few examples then. Just a few of them. Okay, how about this one? How about 20513 in, let's say base 6. No. So everything start from 0 going this way. So this would be so that would be 3 times 6 to the 0, 1 times 6 to the 1, 5 times 6 to the 2. That will be 0, and this would be 6 to the 4. Put them in black and see. So we'll have that to the 4, that to the 3, 2, 1, and 0. Now, you know, I'm going to do the reverse as well. So let's see how best it works if we're going back and forth, right? So all right, let me write them in red over here now, since we don't advertise already. Don't advertise, so I can always get rid of this. Alright, so let's start by writing the first number. Any number raised to the 0 is 1. Then we'll multiply 1 by 6 to get 6. Then 6 to the 2 will be 36. Then we'll have 216. Alright. Now we're going to have, I believe this is going to be 1296. I think so. 1296. So 0, 1, 2, 3, 4. Oh, well, we don't need to go further than this name. I think we have all the numbers we need there. So that means for this, we have 3 times 1. Then the next one is 1 times 6. Okay, alright, so I think I know what I can do. So 3 times this 1 is 3. 1 times 6 to the 1 is 6. 5 times 6 to the 2. Alright, 36 times 10 is 360. Divide that by 2. So this will be 180. Then, well, this one will be 0. Because 0 times 216. And then now we have 1296 plus 1296. So that will be, alright, 2592. Yeah, 2592, add that to 189. Alright, so in total that's going to be this number right here. Yeah. So now this was base 6. This is base 10. And most of the times we convert whatever base number to base 10 because that is our natural number system. Right? That's the one we're most familiar with. Right? So now that we do that, let's see if I can bring it back to, so if I can go from here to here can I go back from this to that? So let's see if I can do that. So let's remember 2781. So let's try remember that. Alright, 2781. So we converted from base 6 to 10 a while ago. Alright, so what we did a while ago was I know. Really? God. Yeah. So we went from base 6 to 10, now we're going in reverse now. So the number is 2781. So we can use these numbers over here and help us again, right? But what I would do, I'd write them in a certain order. So I'd write it as 1, then 6, 36, 216, and then 12, 96. No, this is actually trickier because when it's binary, you only have one of each number, right? You only have one of each number. So how would you know how much of each of these numbers you need? You know, how much? How would you know? Because okay, you have 1296. So let's say you decided you know say 1296 is not big enough, and you add that number to itself, and you end up with 2592. Well, you know you can at least subtract that from this. So I think I guess the aim is you're trying to find the highest amount out of it that you can possibly get without passing the number itself. So that's the best I can say. Just like when you're dealing with fractions and that sort of thing. Yeah, you're working with the highest number you can use without passing the maximum itself, right? So we have that. So fine. No. Okay. So my trick for this is, if I add 8 to that number, I'm going to get 2,600, right? If I take 600 from the 781, I get 181. So if I add 181 to 8, I end up with 189. Now, 216 is bigger, so we're not going to use any amount of 216 because 216 bigger than that, right? Okay. So okay, just so that it makes sense, so that we know that the largest amount we need, technically what you're doing is, imagine you're dividing this number by this number, right? The most we can get out of that by dividing this by that is the number 2. Then imagine if you did that again with 189 and you divide it by 36. It's like you're trying to see how many 36s you can get out of the 189, right? But you don't actually literally have to do the division. I mean, that's optional if you want to do that, but you can add the number to itself a couple of times and see what max amount of it gives you that number right there. So how many times you can add 36 to itself until you get close to 189. So okay, let me see now. I can have 36, then 72, 108, 144, and 180. Oh, yeah. So now we're actually seeing it. So the max amount of 36 we need is 1, 2, 3, 4, 5 of them. So we definitely need 5 of them. So we can do this. Right? We definitely need 5. So now we can subtract 180 from that. Right? So you can actually count. And now we'll go on. Now we'll go on, because when you look at 6, how many 6s you can get out of the number 9? Only 1. The remainder will be 3. So if you say 9 minus 6, right? 9 minus 6 is going to be 3. So then now, well, obviously you do this. Obviously our last number is 3. Oh, you know what? No, a lie. Guess what? I don't want that in blue. I want that in black. So all the powers of 6, I put them in blue. Right. There we go. Or whatever. Yeah. Alright, so know that that's all we have left. We have to multiply 1 by 3. Right? We have to multiply 1 by the 3. Yeah. So so yeah, if we think about it logically, we're dividing this number by this and say how much of them we can fit into that. Then we pick the largest amount we can get. The largest amount was 2592. We subtract it from that. Then we get 189. We couldn't use 216 because it can't fit into that. Right? So that's why that have a 0. Right? 216 bigger than 189, so we can't use that. Now we try to find how many 36s we could use. Right? So we can fit 5 of them and have it come as close to the 189 as possible. So we use 5 of them, get 180, we subtract it from that. We're left with 9 now. There's only 1 6 we can get out of that, and then we need 3 individual ones. Yeah? And funny enough, it written in order. So you can just write 20513 and that's it. You know, so I guess once you can do this, base 2 binary is the easiest one to do. The easiest one. But I'm going to do another one. And them have the decimal version of these, which, listen man, I mean, it makes sense and it doesn't. Like, I don't know when you would ever need to find a decimal version of like base 6 or base 9 or whatever. It's just madness to me, honestly. It really is. Alright, let's try Lord God, this alright, I'll go to base 9. Base 9 is kind of ridiculous. Base 9, base 7. Yeah. Yeah, man, why would I? And guess what? It makes sense and it don't make sense. Right? Because, okay, alright, I'm gonna do it. I'm gonna do it as ridiculous as it is. As ridiculous as it is to do something that have like the decimal points, I have an idea of what it actually means. So let's say, for example, you've been given some decimal version of, let's say you get something like 0.07154, right? 0.07154, and it's not in base 10, but it's in base, let's say it's in base 8, right? Now here's what I know. I know this over here is at least yeah, sorry, I thought I was gonna sneeze a while ago. This must at least be 8 raised to the 0. Right? That means over here you're gonna have 8 raised to the -1, -2, -3, -4, and -5. Now I can't think of that in any other way. Right? Now here's what that means. It means that you're finding the inverse of what we normally have. So for example, now let me go a step further now. So we have 8 raised to the 1, right? So that means that this is going to be 8. This is going to be... How literal can I get about this? I mean, I can put 1, but it's really 8 divided by 8. Then this becomes 1 over 8, 1 over 64, 1 over 512, 1 over, how that go now? 2 raised to the 3 times 4 is 2 to the 12. 2 to the 12 is... Really? Oh man, them number are too, them number are too massive. So 1 is 2 to the power 15, 1 is 2 to the power 12. 4096. Yeah, right. It's sorry. I kind of fast forward that a while ago. Let me tell you what happened. The number that I remember after, so 2 to the power of 10, if I remember, is 1024. Now 2 raised to the 2 is 4, so if you multiply 1024 by 4, you get 4096. I'm going to try, where is it? Okay, so I have 8. Hold on then. Why the calculator not? Alright, good. So let's show us that now. See? 8 raised to the power of 4 is 4096. Right? So that's why I can comfortably say that. So now, okay, fine. So we multiply this by 8. Oh, yeah. Alright. Yeah, that's a lot of fun. And this is what, 1 over 32, 768. Yeah. yeah. I mean, that seems to be what this should be. Because if we're going with what they've told us about this direction going forward and this direction going over here, right? This have to be the ones place, and then anything else is 1 over 8, 1 over this, 1 over that, blah 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 blah. Right? But yeah, I mean, the only good thing about it is that you know what these are. Because after this, what am I gonna do? I'm not gonna waste my time with this. This, like, what am I gonna do? Multiply 4 by this and then get what? 4 over 32,768. Which, yeah, sure, I can do that. Why not? So I will put 4 over this, because why not? 5 times that, well, this is going to be 5. It not really matter. This is going to be 1 same way. 1 times 1 is 1. This is going to be 7. And then what? These are just, well, 0 times anything that are just 0. Right? So if we were to add up all of this now, I mean, come on. This, I mean, it can do, but this tedious. This is something you give somebody for a project. Like, there's no need to do all of this, because now what you're going to do now is you have to basically find the LCM of all of that, and the LCM of all of that is 32,768. Right? That's really what it is. Right? So let's, I mean, as tedious as that is, if 4,096 times 8 give you that, then you have to multiply 8 by 5. Come on. Oh God. No, this is ridiculous. Alright? So let me see if we can make sense of that. So we already have that, and then the 5 over that is so we have 40 over 32,768. We have 4 over 32,768. So by doing that, we virtually have this and we have this. All right, I could divide so now we have to multiply 1 over this by 64 and 64. So 1 times 64, that means it will be, alright, come on, man. Yeah. Now, man, this is, you're not gonna get this by multiple choice, 1. And yeah, somebody would have to give this as a means for wasted time, because this is, yeah, it's not like it cannot be done. It's not difficult, it's just very tedious. 512 times 7 now. Because, okay, what you're really saying is you have 7 over 64. You want to make it equal to 32,768. But in order to do that, you have to multiply it by 512. So you have to multiply this by 512 and this by 512. Yeah? Yeah, so yeah. We're not going to act like this isn't. It really is. So this is going to be 3584. my God. And then the other one is 0, so we don't have to worry about that. Yeah. Yeah, this is only when you want to be curious and see how far you can go with this. So when we add up everything, we're supposed to get this number, 3692 over 32768. Yeah. And yeah. Let me see now. Really? No, Star, listen. You just do the calculator move after this. Right? Because we can actually, do that, but I don't have time for this now. I mean, again, I could prove that even without a calculator, I can get us to where we want to be, right? Because we have to do this whenever I have a choice. Each number is multiplied by a power of 8, which is in the inverse. So you have 0 times 1 over 8, 7 times 1 over 64, 1 times 1 over 512, right? 5 times 1 over, so yeah, this was kind of ridiculous. It was. So I'm not gonna further on that. I won't. Right? If anybody set a question like that for you, then just want to take up your time. Right? So let's do something a little bit more practical. Like, okay, the real ones, like 5, 7, 6, 3, 2, and that is in base 8. Right? So make we stay. Or you know what? Even alright, this not so bad. If they may give you something like this, and then this was in base 8, this would be so bad, to be fair. So therefore, I forgot to do this, I forgot to do this. And I apologize for that. So after 1 times 8 and then 64, 512, then 4096, and then what do you come after that again? I think it was 32,768. Yeah. So okay. So let's put it in context, right? So that we'll understand where this should be. If we were to add this to up here, then the 0 would be here. And this is where the rest of that would be. Right? So just imagine that this would be a yeah, and both of these numbers are in base 8. So then this would be in base 8, this would be in base 8. Right? So that is why let me put this up now. So therefore this is 8 to the 0, 8 to the 1, 2, 3, 4, and then this now when you go over here now, minus 1, minus 2, Yeah. So that is why that makes sense. So so for example, if you just got this, if all you had was this, then the first thing you want to do is start off this by writing 8 to the 0 first. Right? So one set is to the left of 0 and another set is to the right of 0. So you're going to the right of 0 now, you start going in the other direction now. So you have 8 to the minus 1, 8 to the minus 2, 8 to the minus 3. Right? And I guess it makes sense you work out something like this beforehand, so that way you're not trying to figure it out when you get, if you ever see the question for the first time in your life. Because, in all seriousness, I've never taught this. Rather, I don't even remember getting a question like this. I always get the whole number versions of the base numbers, but to get them in this form, kind of crazy. All right. So 8 to the minus 1 is 1 over 8. Right? Oh, see? So I did this, but I forgot to go in the other direction. So maybe I should do that. Maybe I should do that. So if I'm going back now, I must write 1 over 8, 1 over 64, 1 over 512, 1 over right. So let's see. All of a sudden that now work. What's going on? Alright. Let me see if I can yeah, I want to make sure that all of that is visible. Right. So therefore this would be a 0. This would be your minus 1, minus 2, minus 3, minus 4. This would be your 1, 2, 3, 4, 5. So this way we don't make any mistakes, right? So we're not going to multiply this by 8, this by 64, this by 512. It's the inverse of them, right? So therefore the first number is 6 times, 7 times, and 3 times. So therefore 6 times 1, hold on there, 1 over 8, so you have 6 times 1 over 8, 7 times 1 over 64, and 3 times 1 over 512. Just make sure so we'll have that. And then of course, now the LCM of 8, 64, and 512 is going to be 512, right? So if 8 raised to the 3 is 512, that means I have to multiply this by 64 and this by 8. So okay, let me do this then. Let me try and represent them so that they are visible now. So this would be 6 over 8. This would be 7 over 64. This would be 3 over 512. Then after that now, the base for all of them, or rather the LCM of all of them would be 512. So we'd have, I don't know, hold on. I'm gonna put these in blue. So what? 64 times 6. Let me do that now. Alright, so that's 384. So I have that. We have 7 times 8. So okay, this is multiplied by 64, this by 64, this by 8, this by 8. Alright, so 6 times 64 give us that, 7 times 8 will give us 56. And of course, this don't need to change. You can just multiply that by 1, that by 1. So this is just, yeah, this is a lot more, what do you call it? A lot more tedious. let me see now. 384. And we add that to, yeah. So, when everything is said and done, we end up with 443 over 512. And then with that now, obviously you turn that to a decimal after the fact, which, listen man. Like, this is just a test of your patience, really. And you have to be careful, right? The only good thing is that you know that the denominator go unchanged. So you just multiply the 6 by 1, you have 6 over that. 7 by 1, 7 over that. 3 by 1, 3 over that. Right? So 6 by the 1 over 8, 7 by 1 over 64, 3 by 1 over 512. Right? So we move from this to this, right? Then we find the LCM of the 3, which is the largest one. So we're not even have to guess that part. And then we make them all equivalent and then we add it together. So therefore, when we put all of these 3 together, we end up with that. And you know the crazy part about it, this is supposed to be one of the easier one then. Right? Once it passes 3 decimal, like 3 numbers behind the decimal point, I'm not going to further than that. Not going no further than that. But yeah, this is just in case you're ever in the situation where you need to be able to do this, right? You know, so yeah. But in the other case now, you don't have to worry so much about that because you don't have any fractions to deal with. Right? So in this case now, up here, where all you have is the whole numbers, right? You just, so therefore 8 to the 4 now is what? 8 to the 4 is 4096. Then to the 3 is 512. Obviously, this is just 64. This is just 8. And this is your 1. Right? So 1 here, 8 here, 64, 512, and that. So this will be 2,480. Then we have 512 times 7. Alright, so that's 3,584. And you have 64 times 6. So now you have 384. Oh, that means I need to bring it down a little more than that. Now 3 8's 24. And then the last one, 2 times 1. Yeah, that's it. So now I have 26 plus 3, 84. 410 plus 35, 84. And then we'll just take that and add it to 20,480. So in total now we have 24,474. So that's what this would be in that's what that would be in base 10. So you know, you see, it's clearly a lot easier when you have the whole numbers working with. When you start going down the decimal path now, you're starting to deal with fractions and all of that now, right? So we can do the reverse. I believe we can do the reverse. So let's try. So this was. So let me write it up here. This was base 8 to base 10. So now we're going back. Right? So we went from base 8 to base 10. Now we'll go try and go back. So imagine we never know all of this up here. And what they gave us is a normal number. The number 24,474. How would we convert that now to, how do you turn this into a base 8? So alright, So let's start off with our 32,768. Drop it to 4,096. Drop it to 512. Drop it to 64. Drop it to 8. And then drop it to 1. Alright? So let's see. 0, 1, 2, 3, 4, 5. So we have 5 here, 4 here, 3 here, 2 here, 1 here. Alright. Now, this number smaller than this, so we're not even going to entertain that at all. Right? So we can't use any amount of 8 raised to the 5, because that will not be smaller than this. So now we have to figure out how many 4,096, how many of this number we can fit into this. Right? How many? I mean, you can do it in the calculator. So let's actually, if you have a calculator, then here we go. The amount would be something like this. Now, if we round it off, normally you'd probably want to round this up to 6, but in reality, because the maximum is 5, you just leave off everything else. Right? So in other words, hold on. Let me see. Yeah, see? Yeah, exactly. Because if you multiply this number by 6, you're going to end up with a number larger than 24,474. So we can't use this. We can't use 6 of them. So we don't have to use, yeah, because let's say we did do this. If we subtract that number from, so watch it now, 24,576, right? 24,576. So let me do that. 24,576. See that? Yeah. We'd end up with something negative. That wouldn't make any sense. You get me? So really and truly, even though normally we want to round the number up, if we divide the number 24,474 and we divide it by 4,096, it means that we can only get 5 of 4,096. Everything else will just be a remainder. So we'll just ignore the remainder part then. Right? And we can do this manually, but obviously for save time I'm gonna do that another time. So that means we'll multiply this number by 5. Right? So when we do that now, we get 20,480, so we'll go subtract it from this. 20,480. Alright, so let me put it down here so now. I'm gonna ignore them two there. Right? Let's ignore that. Now if I took 474 from both of them, I'd end up with this. 474 from that would leave me with just this. So add 4 to that, 9 to that, 9 to that, Yeah. Yeah, so my result would be 3,994. So I'm gonna put that up here. And we can do that manually and see how that would have go. Right, so yeah. Right, so now so if we were to actually divide, if we divided this by 4,096, we'd end up with 5 with a remainder of 3,994. That's probably what would that's very much likely what would happen. Right? That is very much likely what would happen. So now we have 3,994. Now we have to work with 512 and see how much of that can fit into that. Right? So let us see. 3,994. Alright, now watch this. Much like what we had before. Yeah? So let's just say we have 5, 6, 7, 8. And the number drop between the 7 and the 8. Once it drop between 7 and 8, we just go dash away everything to the right of the decimal. And we'll go focus on what's on the left. So it don't matter. If it's not exactly 8, then we can't use it. Right? So we have to treat it like we're using like whole number integers. Right? So it's either 7 or it's 8. And if it's not 8, then it is 7. So nearly is not good enough. You understand? Because if I multiply 512 by 8, it give me 4,096. Right? But yeah, this number is smaller than 3,994. You understand? But this number is bigger. So for example, we couldn't use it because anyhow me do this and I do this. No, what may I do? 4,000. Yeah, see? Yeah, end up with a negative number again, right? So it's clear that I have to use what? 512 times 7, right? 512 times 7. Yeah? So I'm going to put 7 times that, and I'm going to subtract it from 3,994. So 3,584 now. This little easier. 9 minus 5 is 4. 9 minus 8, 1. Alright, we have 410. Now again, how many 64s we can fit in that now? So 410, divide that by 64. Again, it drop over the 6. It's not quite 7, so it's going to be 6. Alright, so if it go a little bit over the 6, it's going to be 6. Alright, just like how, you know, you can't have 6.40625 people. It's either you have 6 people or you have 7 people. Alright, you know, go find the fraction of a person or something like that. That makes no sense. Alright, so it's either you have 6 people or you have 7. You can't have 6.5 or 6 3/4 people, you know. No. Right? So we're going to say that we're multiplying 64 by 6. Right? 64 by 6. Because that gives us a number smaller than 410. Right? So therefore, we multiply this by 6. Now we'll go subtract 384 from this. So let's subtract that. No. If I add 16 to 384, I get 400. So 400 from 410 is 10. So if I add 10 plus 16, I have 26. No, 26 look real familiar, don't? 26 look familiar. In the sense that if we compare it to 8, let's divide 26 by 8. So as a whole number, we can only get 3 perfect 8s out of the 26. So we're going to multiply 3 by the 8 to get a number smaller than 26, which is what? 24. Yeah. And now we're left with that. So you just have to multiply this by 2. And that's it. Right? Yeah. Now, I find this to be a reliable way of getting it, because now that you've done it, see it here, 5, 7, 6, 3, 2. You can write it from here, come down, and that's what it is. So don't write it like this, write it like that. Yeah? Because of course, the largest power gonna go furthest to the left. Yeah, so you would flip it around. Yeah. So that never too bad. That never too bad. That never too bad. And it don't matter what we get. If we get base 9, if we get base 7, we can do the whole of them. Right? Yeah. Let me see what else. Okay. Alright. This one is weird because them give you a, what you call it now? them give you a decimal part of it. Right? Them give you a decimal part. So I could see. Let me see what the number is. So this is a base 7 number. Right? This number is a base 7 number. Base 7, base 7, base 7, base 7. So imagine that. A base 7 number with some decimal part on it. Now, again, the good thing is that you know, once you have this, then you know what to do when you start going over here. This is 7 to the 0, then this becomes -1, -2, yeah. So therefore, let me just make them make a difference. So 7 to the 0, -1, -2, -3. 1, 2, 3. Yeah. So this side of it, right? This side is the weird part of it. So you'd have 0 times 1/7. you'd have 1 times 1 over 49, and you'd have 3 times 1 over, what other number again? I think it's 343. Let's see, 49. Yeah, 343. Oh, hold on. Wait there. Okay. Yeah, so obviously that's the weird part of it. So you're going to have 1 over 49 plus 3 over 343. So okay, let me just write it down there. One over 49 and this. So then if we multiply 7 by this, 7 by that, this would be 7 over 343, resulting in 10 over 343. Yeah. Now that's going to be a weird one. Yeah. So if you put this in your calculator, you end up with 0.02915 blah blah blah. Alright, so that's your decimal equivalent of that on that side. Now that's the fun part about this, right? You can literally do this part on its own and then do this part over here. Because this is the harder part, this would be the easier one, right? Because these are the fractions, these would be the whole numbers, right? So this is raised to the 1, 1 times 4, well that is just 4. Right? You have 0 times 7, that is just 0. So you have 0 right there. Right? Then you have 5 times 49. What that now? 490 divided by 2. 343 times 6. That's 6 my purse. Yeah. 20. Alright, so this now. Okay, this is 17. Carry 1. Really and truly, maybe use a different color then. Alright, 5 plus 5, that's a 10. Again, different color. Alright, so 2,307. Right. So if you wanted to know what this is as, you know, base 10, you add this to that, of course you'll get 2,307.02915, whatever. Alright? So you can do the whole number and the fraction separate from each other. Alright? Let me see something. Yeah. Yeah. You see how weird that look? Imagine that 6,504 in base 7 is this in base 10. And of course we can go back. Now mind you, like this now, like come on, I not go back with this. I'm not converting it reverse for this part. Like why? Yeah, then that it's not that it cannot be done, you know. It's just me not feel like waste my time. I feel like do that. Right? Well, it's good to know we know how to find this part. So seeing that we know that this in base 7 gives us this, or wrong column use, in base 10 well, let us try and go back. Right? Let us see if we can get this number on the left with the madness that we did earlier. So let us see. So what would it be? You have 2,307 and you have so hold on, you know. We have to think about all the number them in base 7. 343. Okay. So let's start from this crazy one. 2,401. Right? Then we have 343. Then we have 49. Then we have 7. Then we have 1. Right? So then this would be our raise to the 0. Now the first thing we notice is this is larger than this, so we can't use any part of 7 raised to the power 4. Simply because if we subtract 2,401 from this, we're going to end up with a negative number, which don't make no sense, right? So therefore, the number has to be smaller than this. So therefore, we have to find out how much of 343 can fit into that. Alright, so looking at this now, the number is between 6 and 7. If it is not 7, you drop it to 6. Because again, you can't have 6.725 people. You understand? It's either 6 or 7. Alright? So yeah. So we're multiplying this here number by 6. So let's see what happens now. 343 multiply that by 6, you get 2,058. So we're going to subtract 2,058 from this. Alright. What do I do when I'm in this predicament now? So I'm going to check the system now. Okay, fine. So more I get to let me jump to 100 first. So if I do that, I will get to 100, right? If I take away 100 from 307, I get 207. So if I add this now, my number should be what? 249. So let me see if that works. Yeah. 2,307 minus 2,058 from that. Yeah, man. Alright, so now we have 249. We don't have a choice. We have to work with 49. So let us now divide that by 49. Now look at this. It gave us 5. Right? So we're going to work with it. We're going to work with the 5. Right? And the reason why is because if we were to use 49 times 6, we'd end up with 294, which is bigger than 249. Right? So if we try to do this, yeah, that's what you'd end up with. So we have that. Right. Oh, the number, not the number. What was the number again? 49 times 5. A 46 we type a while ago. 49 times 5. 245. There we go. Alright, this is interesting. 245. Now look at what happened here now. Now I cannot use any amount of 7 at all. I have to use 0 times 7. Yeah? 7 bigger than the 4. There's no way. Right? So now finally, how many ones can fit into 4? It would have to be all 4 of them. Yeah. So you would just have to use that, and there we go. So our final answer for this yeah. So therefore this in base 10 would be that number right there in base 7. Yeah. So I guess it don't matter what base number we get. I mean, to be fair, the easiest one is going to be base 2. We're going to do a base 9 and then go to base 2. Because if you can't do anything higher than base, let's say, if you can't do base 3 going up, then when you get to base 2, it's a joke thing. It really is. Alright, let me do, I want to do one from base 9 that's, you know, what number can I use that's in base 9 that, okay. Then make sure yourself I put the 0 them in there. They put the zeros in there just to see if you're paying attention. Alright, so let's try 8,160 in base 9. Hold on, man. Yeah, that means to look like a 9. Alright. Oh. I had this here for how long and did not remove it. Okay. Where are we now? Okay. Yeah, these numbers are massive though. Yeah, these are bigger numbers, right? Okay. So we'll start with our 1, go up to 9. Start with 1, go up to 9. 81, 729. Hold on, make sure that that number is a little more visible than that. Alright, 0, 1, 2, 3. And you know what? I guess just for the chance, just say 0, 1, 2, 3, 4. Just in case there's one like that. Oh, yeah, why did I forget this number? 65, 61. Okay. Alright, so here we are. This is to the power 2, 1, 0, 3, and 4. Alright, so we have that now. Alright, hold on, give me a second here. Okay, oh, sorry, this is a madness. I need to erase that. We don't know what the answer is yet. We're trying to convert it to base 10. We don't know what it is yet. So, okay, so we have 0, 6, 1, and 8. 0 times 9 raised to the 0. 6 times 9 raised to the 1. So 9 to the 0, 9 to the 1, 9 to the 2, and 9 to the 3. So that's what is really happening. Now, so that we feel a little more at ease, you would be replacing each of them with the numbers that you have over there, right? So this would be 6 times 9, 1 times 81, 0 times 1, and 8 times 729. So this would be 54, 81, 0, and then we have 729 times 8. So we have 5,832. And now we just add what we see right there. So we add that to what? 135. Alright, so we have, so our number is 5,967. Alright? So that would be our result in base 10. So now that we've done that, let us see if we can go back to see if we can go back to base 9. So we did base 9 to 10. Now we're going back. So we'll get rid of all of that now. So the number we are working with, and let me just working with this number, Right? So we have 5,967. So we have that. Now, if you notice, this number is bigger than this, so we can't use 9 to the power 4 at all. Right? So everything needs to be 3210. Right? The question is, how many of 729 we can fit into that? So let's see. The largest number, or the largest amount of 729, well, that's going to be 8. So we're going to multiply 8 by 729. So let's see what happened there. 5,832. Alright, this is not too bad because everything come out with the top numbers being larger. So this would be 9 minus 8 is 1, 6 minus 3, and then 7 minus 2. Okay, so we have 135 and we have 81. How many of the 81s we can fit in that? Yeah, we can only fit one. We can only fit one. Right? So we can only fit the one of that. So let's subtract the 81 from this. So what that will be now? 81 right here. I start to see 5 minus 1, that is 4. 8 plus 2, 10. 10 plus 3, 13. So 2 plus 3 is 5. And life is good. Because now it's perfectly divisible. Right? If we divide 54 by 9, we have no remainder. Right? No remainder. So therefore, we have a 6 times 9 here and a 0 down here. Therefore, our answer is going to be and we read it from that way. Now if you can do base 9, 7, 6, 5, 4, 3, if you can do all of those, then when we get to base 2, you have 0 worries because you don't have as much. The part where you divide something by the other, you don't have that to do. So it's better to work from this and come back to the base 2 rather than when you get to the base 2 and go up. Now you wonder how you're gonna get those numbers, right? So if you deal with it like this, then it's a breeze. Now we're gonna go to base 2 now, and base 2 is just zeros and ones. Zeros and ones alone. You're not for worry about nothing else, right? Zeros and ones. Let me see if I can find some of them. Okay, but that look like some decimal madness. We don't want that. Alright, I know what I'm going to do. So let me just create the, you know what? Why not? Why not use these numbers and try and convert them to base 2. So just imagine that these are both base 10 numbers anyway. I will go convert them to base 2. Might as well. So now there's a lot of numbers that we can start from the most ridiculous. Yeah, we can. Let me see. Dear God. 4096 plus 4000. Yeah, man. See there? Alright, so watch this now. We have the number 8192. Yeah? Now let me divide it by 2 just to be sure that what may do make sense. So 4, 6, 8, 10, 12, 14, 16, 18. Alright, so 1, 2, 3, 4. Now this is one smaller everything, so that's a 0, right? And then now we have 19. 19 is bigger than 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. So 19 minus 18 leave you with 1. 12 is exactly 1, 2, 3, 4, 5, 6. Yeah. Okay. Yeah. So that take care of that. Cool. So therefore, what comes after that is definitely that. So yeah. So 4096. You divide that by 2. This is 2048. After that it's 1024. Then 512. 256. 128. 64. 32. 16. 8. Yeah. I think we know what go down after that, right? I don't know if I can put it over here too. Right? 4, 2, 1. Right? So therefore, start with 0, 1, 2, 3, 4, 5, 7 minutes. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay. Now, as ridiculous as this is, if we're comparing this to this, 8192 is bigger. It's bigger than 8160, right? Bigger than this. So we can't use that. And it's only zeros and ones we have. So therefore, the largest amount of 4096 would have to be 1. Right? It have to be 1. Right? We're not gonna get no, because all we have in binary is 0 and 1. Right? So we're going to subtract the 4096 from this. Alright. So let me see now. Add 4 to that. I get what? I get my 100 from that. Oh, hold on. Let me be careful. Allow me to be careful. Let's say that that is 4,100 from that. If I take 4,100 from that, right, I'm left with 4,060. So therefore I have, if I add them together, I have 4,064. Now, you can add them and see if that actually work. 4,064 plus 4,096. Yeah, and it work. So, we have at least one of these. So I could just do this. Now, do we need 2048? Well, it's the largest thing after that. So yeah, we can use it. Alright, we can use the 2048. So the difference with this now is that you don't have to worry. The only possibilities you can get with base 2 is 0 and 1. Alright, just 0 and 1. Alright. If I add 16 to that, I get 64. Yeah. So therefore this is, yeah, 8 plus 6, 14, carry 1. Yeah. That's that. So therefore I have at least one of this and one of this. So I have at least one. It will start make sense after a little while. So now, can we use 1024? We can, since it's smaller. So when we subtract that from that now, what we have now? 1016 from that, and 1016 from that is, so this is looking a lot like 992. Yeah, 992. So that means we use one of this, one of this, one of this. Ah. Okay. Now I go add it again just to be sure. 992, and I go add that to 1024. Yeah. Just making sure we have everything in order. So 1024, 2 to the 10, 24, 48, 2 to the 11, 4096. Right, cool. We have that. Well, we might as well use the 512. We might as well, because it's the largest thing that come after it, so might as well use it. So we have 512 from that. This leaves us with 480. Alright, so one of each of these. then we have to use 256. Anyway, alright, so I could write the 1 times 256. Now, if I add 4 to this, alright, 0 carry on 1, 8 minus 6, that give me 2. So, yeah, 224. Might as well use the 128. $128. 100 minus 4 look like 96. Okay, well, we just have 2 more things. We just have 2 more for do and we're done. And this is how I know. If I take 64 from this, I'm left with 32. And I take 32 from this, I'm left with nothing. If I add 64 plus that, I end up with 96. So I know that I'm going to have 64 and 32. So if I add 64 and 32 and I get 96, I might as well say 1 and 1 and then 0 for everything else. Right? Yeah. Yeah, that was a big number. That was a big number. So this is 1 1 1 1 1 1 1 1. How many of them? What? Oh, that's a lot. Yeah, that was more than I thought it was. So 1 2 3 4 5 6 7 8. Yes, yes. So 8 ones, 5 zeros, and 8 plus 5 is 13. So yeah, that kind of makes sense. Kind of makes sense. So yeah, if we can, boy, this. So 1 1 1 1 1 1 1 1 1 2 3 4 5. This entire thing up here in base 2 is what that is. Base 2, if we're converting base 2 to base 10, I believe that that's a lot easier to do. Whole heap easier. Now this was a bit tedious because of the number that we had. The number was kind of big. You know. Number was big. So first we use 8,160. Now let's see what happens if we use something like, so we're done with this one, right? We're done with that one. So let's try 5,967 and see what ends up being our case right here. So I could get rid of that. Let's get rid of that. We could still keep this. And let's get rid of that. Get rid of that, and let's put down here 5,967. Oh, I don't need these zeros here either. Yeah. Okay. All right. So obviously we can rule out this. We can rule out the 8,192. We can rule out that. Now we can use at least one of the 4,096. So let's use one of that. So we have 4096. Alright, let me make my life easy. If I add 4 to that number, I get 4,100. Alright, 5 minus 4 is 1. 9 minus 1 is 8. 6 minus 0 is... I don't know. What am I doing a while ago? Right? So 4,001 from that. Yeah. And if I add this to that, I'd get 1871. So let me write that now. 1871. Alright, good. Now here's the problem. 2048 is bigger than this. So now we will have to put a 0 right here. So we can't use no parts of 2048. Now we have to move to 1024. Let's use one of 1024, right? So we have 1024. What do I add to this to make my life easier? So if I add 6 to that, carry 1, 3 plus 7. So I have that. If I take 1100 from that, I'd end up with what? 18 minus 11. Yeah. So now that's going to be, well, if I add the two of them, this is going to be 847. Right, so 1 carry the 1. Yeah. Alright, no, 512 can definitely fit, so we might as well use it. So let's put 512 into this. So this will be 7 minus 2, 5. This is 3. This is 3. Then you can fit 256. We don't forget that. Right? So might as well subtract the 256 from this. So 256. Alright, 44. If I add 44 to that, I get 300. So 44 plus 35. So add 44 to 35. What that? That's looking like 79. So that's looking like 79. Make sure I write that little better than that. Now 256 plus 79 is in fact, yeah, 335. Alright, so we just want to make sure that goes on. Now 128 is bigger than this, so we can't use it. Alright? Yeah. So we couldn't use any of 2048. We couldn't use 128. Now we can use 64. So let's subtract 64 from all of this. So we have 64. So I'm going to put a 1 beside it. 9 minus 4, we have 5. 7 minus 6. A lie. So 79. Yeah. So now we're not a good spot now. 15 is smaller than 32. We can't use any amount of 32. And it's also smaller than 16, so we can't use that neither. So what's your joke now? We don't have a choice but to use 8, 4, 2, and 1. Because what? 4 plus 2 is 6 plus 1, 7. 7 plus 8 give us 15. So we have to use one of each. So 1 here, 1 here, 1 here, and a 1 right there. Yeah. Yeah, it's a shame. Obviously, you know what? It's okay. I can make the adjustment so that it makes a little bit more sense. So let me try and move this up here a little bit, and then yeah, why not? So we knew what we were doing, right? No, we're converting that to base 2. All right. So we have 8,192 here, 4,096, 2048, 1,024, and then we just let's write it over so that we have everything we need. Alright, hold on, you know. So after this we have 512, 256, 128, 64, 32, 16, 8, 4, 2, and then 1. Right. So this was to the power of 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, and of course right. Now what we said we could not use was the 8,192. Right, we used one of 4,096. We used 2048. We used one of 1,024, one of 512, 256. We didn't use any of, we never used 128, but we used 64, and we never used 32 or 16. But then we used 8, 4, 2, and 1, 8 plus 4, 12 plus 2, 14 plus 1, right? So we used one of all of that. So if we write it in this order now, coming down, yeah, and that should take care of that. So okay, now that we've done that, if we were to write it, it would be 10111 01001. Yeah. So this would be the base 2 of the number of this number in base 10. Yeah. And if you can do the difficult ones, you can do the easy ones. All right, let us say I wanted to say convert 87, that's in base 10, and I want to convert that to base 2. Well, let's see the first number that 87 bigger than, or rather, let's take out the first number that's bigger than 87 actually. It would be 128. That's the number that would be bigger than 87. So we'd have to start with 64 going down. We can't go above 64. So that means if we subtract 64 from this, we have a better idea of where we stand. So we have at least a 64. When we're done, we're at 23. Now, that means that 23 smaller than, it's smaller than the 32, so we're now going to be able to use that. So we now have to skip to 16. Right? We'll have to skip to 16. Now this is 7. Now what I know about 7 is that if you add 4 plus 2 plus 1, you get 7. Right? So therefore, we would, okay. So just so that we understand what just happened, we'll be using a 1. We don't use a 32. We use a 16. We don't use any 8, but we use one of these. Or rather, yeah, each one of these. So therefore, 87 would be, just so that, let me just write it so that. So we would have 1 0 1 0 1 1 1. That would be our, this would be our base 2 equivalent of the number 87. So let's see, 0 1 2 3 4 5 6. 2 to the 6, 64. We don't use any of the 5, but we use what? 2 to the 4. Yeah. So we use 2 to the 6, 2 to the 4, and then we use 2, 1, and 0. So we don't use 2 to the 5, and we don't use 2 to the 3. Yeah. So if you can mash up the bigger number them when you get back to the smaller ones, it just, everything work itself out. Alright. Give me 1 second, hold on. Give me 1 second here. Okay. Right. Yeah. Okay. I suppose I can get rid of a portion of this, right? And sometimes you can just think of a number that's just a little bit bigger than any of the powers and see what that would look like. So let's say you wanted to use something like, let's say you did want to say 997, and you wanted that as base 2. Well, you look at the numbers that you have over here. 1024 is bigger than this, so you know not to so you're not going to entertain the 1024, right? Because 1024 is bigger than 997. So the largest number that can fit is your 512. So you subtract your 512 from that, right? Subtract your 512 from that. I notice I color code it, right? So now 9 minus 5 is 4, 9 minus 1 is 8, this is 5. Now we have 485. So we're probably going to use the 256. Right? We might have to use that. Right? So let's go to the 256. If I take 3 from that, that's like 185. What did I add to this to get that? 44. So that will leave me with 229. Yeah. So therefore, my next response is 229. Now, you know what you can do too? I mean, only if you feel like doing that. 512 is 2 to the power of 9. And this is 2 to the power of 8. So sometimes you can just put the numbers there to kind of remind yourself, you know, where you are. Let's see now. Well, you might as well use 128. Might as well, right? So let's use 128. 2 minus 1, 1. 2 minus 2, 0. That 101. So this is what? To the power of 7? What else we're doing now? 101 bigger than the 64. So let's use the 64. So 64 plus 36, give me 100. So 36 plus 1, I will have 37. Now I have 32. Life just get nice now. So now I can subtract 32 from this. Leaving me with 5. And I know that that is 4 plus 1. So I can put a 0 beside the 16, 0 beside the 8, a 1 by the 4, nothing in front of the 2, and 1 by the 1. So now when I'm ready, I just, let's just put this. So what number is this? You have 5 ones, 2 zeros, 1 0 1. So this is your base 2. And that is your base 10. Yeah. Yeah. Oh yeah, I forgot to write the 6 and the 5 right there. Forgot to do that. Right? This way you remember. You have a 6 here, you have a 5 here. And the only thing else you used was what? 2 to the power 2 and then 2 to the power 1. Yeah, we never use the 4 and the 3. And the numbers do help, right? Because if you have 0 here, 1, 2, 3, 4, 5, 6, 7, 8, 9, it tell you what we never use. So we never use 1, we never use 3, and we never use 4. Yeah. So we used, right, we used 1 of this, 1 of this, 1 of this, 1 of this, yeah. And it match up. Because 1, 2, 3, 4, 5, yeah, 1, 2, 3, 4, 5. And then we never use 16 or 8. There's a 0 beside each of them for that reason. And then there's a 0 beside, yeah, beside all of that. Yeah, you know, hopefully this was, you know, I mean, I don't like the repeated division. I mean, you can do that if you want, but yeah, that method was always dodgy for me. I mean, I remember doing it in school and it wasn't really something that I wasn't really fond of it, right? But doing this, when you do the subtractions, you get in your practice anyway. So if you ever struggle with subtraction, you can always practice it doing this, and then at the same time, you are, you know, you're making sense of how large the numbers need to be. The largest number, smaller than 997, is 512. Subtract it from it, you get 485. Now we have to move from that. What's the largest number smaller than it is 256. Then you get 229. The largest number smaller than it is 128. Do that subtraction, you get 101. The largest number smaller than that, 64. Take it from that, you get 37. The largest number smaller than that is 32. And that leaves you with 5. And of course, 5 minus 4 leave you with 1. 1 minus 1. That's it. Alright, so really and truly, I should have done this. 5 minus 4 and then of course you're left with 1 minus 1, right? So we use 1 plus 4 plus this plus this plus this plus this plus this. If we add up all the numbers in red, it gives us 997. So let me do that as the final act, right? 1 plus 4 plus 32 plus 64 plus 128 plus 256 plus 512 and it give it back with 997. Yeah, that 997. All right. I'm at my limit. I'm at my limit. So ideally now, I want to do this Tuesday to Thursday, usually during the afternoon, so I start at 12. So yeah, Tuesday to Thursday, I start at 12. If I'm a little early, maybe I'm a little early. If I'm a little late, I'm a little late. So maybe I could be 5 minutes earlier, I could be 5 minutes late. Alright, but usually around 12 in the afternoon. So anyhow, hopefully this wasn't too stressful on the brain. So anyway, yeah, so Tuesday, Wednesday, Thursday, start at 12, I'll do this again.